Yay. Okay, so I want to start by telling you a story. About 3.5 years ago, me and my wife decided to adopt a puppy. This is Blizzard. And, as time went by, Blizzard grew larger, fluffier, larger still, even larger, and then winter became a horrible werewolf. And I'm going to show you a video of Blizzard. Blizzard is a very active and fun dog. He runs around like a devil, jumping on stuff, going here, going there. And in this video, I'm going to show you, I want you to look at his ears as he's jumping. And if you can kind of figure out what goes on with his ears, then you'll understand everything that I have to tell you about today. So, you guys ready? I know maybe you haven't had your coffee, but I need you to be with me. You guys ready? Yeah. Okay, we'll work on that. Okay. Awesome. So, thank you very much. It was fun. My name is Opher. I'm a creative developer at a company called Echo, where I work on interactive videos. What are interactive videos? So remember, as kids, you had books where you'd read and it'd say, if you want to save the princess, go to page 91. And if you want to chill out and have some beer, go to page 80. So that's the exact same thing, only on the web with video. And an interesting tidbit is that my name is in Hebrew. And in Hebrew, most names have an actual meaning to them. So Opher is a young deer, or a fawn, or Bambi, if you will. And I'm not here to talk about Bambi, but I do want to talk about a different Disney movie, one that came out in 1994. Do you know which one that is? Any guess? Right, so that's true, that's The Lion King. And The Lion King is a very special movie for me, because it was the first time I looked at one of these amazing animation movies and realized that there's something more going on here. I mean, there's so much more than the story. There's some magic in this movie. The Lion King tells a story of a young lion, Simba, who gets disenfranchised from his pride and by his evil uncle Jafar or something, and then comes back to take his place. That doesn't matter. The Lion King was a really good movie, but it wasn't perfect. And it wasn't Disney's most original movie either, but there was just something so special about this movie, at least for me, because it was the first time I saw scenes like this, and I thought, wow, these are, in fact, just moving pictures. These are drawings people made, and they convey so much emotion. And I wanted to understand how come we're looking at this and we have so much feels in us. So, I grew up, I read about it, and I came across this book, The Illusion of Life, by Frank Thomas and Ollie Johnston, which came out in 1981. And these guys are two of Disney's master animators from the Golden Age. And in this book, they lay out 12 principles of classical animations. These principles include squash and stretch, anticipations, arcs, actions, timings, exaggerations. We're not going to go through all of them, because that would take an entire curriculum of classical animation studies. But I want to focus on one in particular, and that is follow-through and overlapping action. So what exactly is follow-through and overlapping action? So take a look at this character, for example, and its cape, and see how the character and the cape interact. Let's zoom in a bit further. Have a look at this carrot. You see how there's the carrot body, and there's the leaf, an extension of the body, and the leaf starts moving before the carrot and ends moving after the carrot. It's like a really simple thing, but a very powerful thing. Let's break it apart even further. Follow-through is the act of the leaf starting before and ending after the movement of the main body of the carrot. overlapping action is the offset between the direction of the leaf and the direction of the carrot body. And the two of these actually define different aspects of the same thing. So this also gives a lot of life to an animation. So you can take a look at this animation. It's really nice, but it kind of feels weird and robotic. And if you add overlapping action, suddenly this thing feels much more alive. It also allows you to define the type of material or different feel something has. And this is, you see, it's the same exact drawing with the same exact timing, but only this overlapping action and fall-through makes the material appear different. So let me show you some more examples from a show I'm not going to name. This is an Israeli animator by the name of Eran Mendel who did these for each and every episode, like little tidbits, really cool stuff. This one is super cool. Take a look at the little strand of hair as the hound chops off heads and logs, how it just continues moving past the animation. Or this one, because it has a dog. And who can forget the season finale? And I'm sorry if I'm spoiling anyone, but like the date has been due. So the amazing season finale that we just had a couple of months ago. Okay, so you might ask, okay, this is super cool, but like we're at the JSConf, and why am I talking about these sorts of things? So this is very applicable to what we do as developers, as web developers. Take a look at this example from Code Drops. I'm going to open up this dialog and see how it whizzes past as it flies in and flies out from the screen. This is just by animating the borders of this window. Or this example where you have a modal, and if you drag and stop dragging, then you have this really nice staggered motion, which gives a lot of character to a simple, really simple thing, like a modal. It conveys emotion. It gives some levity to the whole thing. Okay, so you can trust me, but Google says the same thing. This is from Google's material design page, and they say, okay, if you have an app, and you need to show some elements at the same time to the users, don't have them all appear exactly at the same time, because that's really disorienting for the user. Instead, have them appear one after the other in a staggered manner. Again, overlapping each other and staggering. Okay, this is another example where they show you how to have elements appear one after the other. Or how about this one, where they animate a card by showing first the image moving, and then the icon, and then the text. This is something I made at work. It's a little spinner thing that a user sees before the video actually loads, which uses the same principle. It's a simple animation. It's just like 3 circles moving. It sounds like not a big deal, right? And in a sense, it isn't. But there is some trick to the implementation. It's not as straightforward as you might think. And I'll show you how to implement this in in a few different ways. But first, let's take inventory of what we're going to do. So we have 4 circles. Why 4 and not 3? Because one always exits stage right, and one enters stage left. And there's the total iteration time, which is how much time the entire looping animation takes. That's 1 second. There's the circle movement time. How much time does each circle take to move? That's 0.5 seconds. And there is the stagger time, which is how much time does each circle wait before the last circle moved. That's 0.15 seconds. Okay, these are the specs for our animation. And I'm going to show 3 different options on how to implement them. These are not the only options, but these are the options that I oftentimes use. The first one is classical CSS. You just do it with CSS. The second one is with GreenSark or GSAP, JavaScript animation library. And the third one It's kind of a new contender to the game. It's the Web Animation API, or WAPI, which is a new API currently being implemented in modern browsers. WAPI doesn't really have a cool logo, at least not that I found. But to me, it kind of sounds like the sound this meme would make. So there, I made a logo. Cool, so let's start with CSS. And just to start off, let's talk about a little bit of the pros, is that CSS has good animation, good performance for the animation. If you're using the proper performance properties, and Anna is going to be hopefully talking about that later, so do check out her talk. And also, it is defined using only CSS, so you can kind of separate your logic from your animation, if you will. But it isn't perfect, because nothing is. So CSS is kind of has a limited feature set in what you can achieve with it. And if you have to make complex animations, ones that rely on each other and synchronize and all sorts of things, it gets really difficult. And you can't do dynamic animations. So dynamic animations are ones where you want to do physics, for example, where a ball jumps differently depending on how you move the mouse or something like that. So that would be much harder to achieve with CSS. It's really hard to debug. The tools are getting better, but you can't kind of like scrub the time like you would in the good old Flash days. Cool. So just a really quick, short recap on CSS animations. So essentially, you have a keyframe, which is this thing here, which defines several frames and their percentage. So at 0%, we move by nothing. At 25%, we move by 100 pixels, and at 100%, we move by 400 pixels. Then we apply it to the span, which is just like the only thing that we have here. With the animation property, give it the name move, then number of seconds, the amount of time that the animation is going to take, and whether it's going to repeat how many times, or infinitely in this case. And so you see this little circle moving. Cool. So let's implement our circles. Let's first do it without any staggering motion. So I'm not going to go through this, just to show you that there's a keyframe here, and you translate it from 0 to 60 pixels. That's it. OK, so let's make the staggering effect. Add animation delay, a CSS property which delays the animation, as you would expect. Cool. So kind of same thing, only this time. For the first circle, I give it the animation delay of 0. The second one is 0.15. The third one is 0.65, so on and so forth. Let's see how that looks. And yeah, that's not what we wanted. So what just happened? Essentially, animation delay only delays the first run iteration of every animation. It doesn't delay every time the animation repeats, which is kind of annoying, and leads to this thing, where if you take a look at how the animation flows, the first circle started, then the third, but before the second finished, the fourth started as well, and that's like not what we wanted at all. So this is what we want. We want the fourth one to start, then the third, then the second, then the first, and then the whole thing repeats after 1 second. So let's take a look at how this animation would look like. What are the keyframes that we know about? So 2 of them are really simple. At 0%, which is here, you don't move the thing, so you don't move it. And at 100%, you want it to be at the end of the animation, so that's 60 pixels. That's this one here. What about these 2, the one here and the one here? So we don't know the percentages yet, but we know that this is the actual animation, so it moves from 0 to 60. So let's hopefully, now that we're much more awake, we can do some math. It's not a lot of math, I promise, but let's use math to figure out the transition. So 0% is 0 seconds. We know that. 100% is 1 second. We know that. This one, letter here, means that we want to start at a delay. What is the delay? Twice, because there were 2 circles before. So that's 0.15 twice, 0.3, divided by 1 times 100, you get 30%. This one is the exact same thing, only we add the animation time, which was 0.5. And now we have 0.3 plus 0.5 divided by 1 times 100, 80. Yay, OK. We know the exactly where to put our keyframes. How do we implement this? Well, we can leverage the power of SASS because we need a different animation for each different circle. So SASS allows us to do that quite concisely. OK, I said concisely. So let's take a look at the first and the only mix-in that we need, which is exactly what I just said, but implemented in code. So you have a mix-in that takes the circle number, the animation time, the total time, and the delay amount, and does the same keyframes that we just saw. One for 0%, one for the percentage, the calculated percentage for the frames, one for 100%, and one for the calculated percentage for the third frame. OK, and then how do you use this? You just make a for loop with SASS. And for each circle, you use this mix-in to create an animation, the proper animation for the circle. And you apply it like we saw earlier. By the way, this code is going to be up later if you want to take a look at it as a reference. Blah, 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 we have our animations. And it kind of looks a bit like this. So, yay, we have our animation with CSS and SASS. Do note that this creates a whole lot of CSS because you have to create 4 different animations for each of these circles. And if you had 20, then it'd be 20 animations, which is kind of, kind of a lot, more than you'd want. But I'd use this animation for loading. So it makes sense to have just something ready. And so you don't need to load a library to show the users something so that he can load while he loads. Cool. So that was a bit to take in. How many of you people work from home sometimes? Like, yeah, so we have a few. I can't do that because of this. You try to concentrate with that thing staring at you. Anyhow, let's move on. GreenSock is a JavaScript library for animations. Let's take a break down a bit about the pros and cons of GreenSock. So first, it has a really great, robust API, so you can do quite a lot with it. Every conceivable type of animation that gets complex, the API allows you to do. It allows you to do dynamic animations. Like I said earlier, if you need something that changes dynamically or that has uses physics or something like that, you can hook into GreenSock and use that. And it handles browser inconsistencies. So this is especially true in cases where you work with SVGs, and SVG is notoriously differently implemented across different browsers. So GreenSock kind of unifies that. But nothing is perfect, like I said earlier. It's a JavaScript library, so you need to load that JavaScript, which is extra bandwidth, extra parsing time. It's not a big library, but still. JavaScript, as you might have already come across that, is implementation sensitive. So if you have stuff running on your main thread, which locks up the main thread, maybe you're doing a complex calculation or analytics calls that take too long for some reason or something like that, that would halt the execution and make the animation jaggy. So you need to be sure that your JavaScript execution is as optimal as possible so that the animations themselves don't stagger or jank up. And lastly, some advanced feature of this library costs money, which is not necessarily a bad thing, because I guess the amazing team behind it do need to feed themselves somehow. So I'm all up for giving them money. But I'm not one of them, so it's not like affiliate or something. And how do you do the same thing with GreenSock? That's it. So let's take a look at how this thing works. In Greenstock, we have something called a timeline, which is, if you ever worked with Flash, is kind of like the same concept, where you post animations on a stream of events called a timeline. And so we create a new timeline called timeline max, and we make it repeat -1, which means repeat this animation exactly, not one time. Actually, it means repeat it infinitely. And we specify repeat delay. That means after the animation is done, wait a bit, and then repeat it. And then we use this enlarge. Okay. We use this stagger from to handy function call, which essentially means take a bunch of elements, spans, in this case. These are the spans that I'm talking about. And stagger each and every one of them. So stagger, animate them one after the other. This is the duration of the stagger that we saw earlier, 0.5 seconds. And the start, the from section, is from 0 pixels to 60 pixels. And then the stagger time is the amount of time, again, that you wait between animations. And then you have it, like, with a few lines of code, which is pretty cool. OK, but we can do more. So I talked about doing dynamic animations. How does that work? Let's have an example. How come my arrows were so large? OK, so in this example, I have the exact same animation, only now I can click on it, and it reverses mid-animation. And this is one of the strengths of dynamic animations. You can, once you have a timeline, you can hook into the API of that timeline to control it. So you kind of scrub through the timeline the same way you would scrub through a song or something like that. You just take the animation and start playing with it. And that's pretty cool. OK. WAPI. I'm just like, I have so much fun saying that, even though. So WAPI is an animation API that's currently implemented in Firefox, Chrome, and Edge, if I remember correctly, but not fully. You have to look at the table to see what is what, because it constantly changes. And the idea behind it is that as a developer, you can hook into the JavaScript, into the CSS rendering engine that you have when you do CSS animations, but you hook into them using JavaScript. So instead of animating using JavaScript, you just set up the animation using JavaScript, and then the browser takes care of the animation as it would have if you would implement it in CSS, but dynamically. What did I just say? OK. So here's the same exact animation, but this time it's implemented in WAPI. So not going to go through each of the lines, but essentially the same calculation that we saw for the CSS is applied here. You calculate the offset of each frame using the same calculation and give it the same property that you would. And for each of the circles, you use the WAPI function animate to tell it, OK, this is the animation that you want to make. So instead of having to now specify in CSS 4 different animations and loading them, you specify them in runtime and have the browser take care of them. So it's kind of like a mix between having an all-out JavaScript library do the thing and an all CSS animation doing. It's kind of like taking some of both worlds to create this new thing. OK, so by now, you must be asking, great, I just showed you 3 ways of doing the exact same thing. Which one should you use? And the answer, like with any other of these type of things that you ask yourself when you're doing development from the web, is it depends. Simply because by the way, this is an amazing code pen by Rachel Smith, which just Okay, anyhow, why should you use one or the other? It really depends on your use case. So like I said earlier, in my use case, I did a loading animation. So when you're doing loading animations, you don't want the users to load another thing just so he can see the loading animation. But if you have complex animations that you need to synchronize with one another, and they need to start at a certain point, or start at a certain time, or stop, or maybe you have an animation where it happens on a mouse over, something starts to happen, but then on a mouse out, something else needs to happen. It's really, really difficult to do this with CSS. It's easier to do them with JavaScript. But maybe there's a way to do that with WAPI as well. So it's really not a one solution for everything. Instead, it's best if you kind of know the methods that you have, like the tools at your disposal, like the ones I just showed you, and use the ones appropriately. Okay. If you want to read more about this in not a talk form, but an article form, I wrote an article on CSS Tricks called Repeatable Staggered Animation, 3 Ways, SASS, GSAP, and Web Animation API. Catchy, I know. But it has all or at least most of the information that you just saw, and you can kind of dive deep into both the calculations and the different options that you might have, and there's some good discussion in the comments there on different implementation methods. So, thank you so much, both from me and from Blizzard. And before you go out to fetch your coffee, I have one tiny small request from you. And that is, my wife is left home taking care of Blizzard, and I want to show her that it was worth it for me to go here. So I'm going to take a selfie with you. Can we have the slides, please? Yes, no, yes, no, yes, no. Please, pretty please. Take a second. It's all right, they'll do it. Okay, they'll do it. Just prepare myself for this selfie pose. This is, by the way, kind of like the normal size of Blizzard. Yay. Okay, now you need to look happy. like you enjoyed the talk. Woo. Thank you so much.